Hello friends, today we are going to discuss about Kubernetes deployment. What is Kubernetes deployment, how it works, and all the required parameters for Kubernetes deployment. So let's start. So before we begin with Kubernetes deployment, let me check my Minikube cluster. Minikube status should show me, okay. So my control plane is running, Minikube cluster is running, and I can go over the cluster and see the control pods are up, running, and yeah, so we are ready to go. Let me share my another screen. Okay, so we have seen earlier that Kubernetes has something called as a pod, which runs single or multiple containers, and that pod is the smallest manageable unit in Kubernetes cluster. When we run an application inside the container, we need to specify a couple more things. For example, the resources required for that container, how many CPUs or how much RAM that particular pod or container requires, then how many replicas of that application you need. Is there any volume need to be attached, their secret, their config maps, all of these things associated with pod are required to provide when you provision those pods. And when you collectively create or associate it with together, we call it as a deployment. So if you see deployment typically looks like this file, it's a deployment. And then we have the deployment name as a web server. That web server right now running a single replica. So single replica means it is having just single pod running. And we specify Nginx image. That Nginx image is web server, that is version 1.17. We also specify which ports we want to expose. This is a typically container port where application is running. And we also specify resources. So there are two types. One is request, the other one is limits. So request is minimum resource should be available to the pod, a minimum CPU and minimum memory, and limits is maximum it can go up to. All right. So we do create this deployment.yaml file. Then we run the deployment. When we run the deployment, it creates the replica set. So replica set usually maintains versions or history of that deployment. So if we say there are multiple deployments, let's say 1, 2, and 3, and now we are in process to deploy our fourth version. Version number 3 is running in your cluster. If something goes wrong with your current deployment, if that pod starts crashing or your application is not working as expected, or if you find any bug in your application, then it's very easy to roll back to the previous version. It's very single command kubectl rollout, and you can easily roll back to the version 3. So version 3 will be deployed back into your application, and your application get back running online. And then you, in deployment, you specified how many replicas you want to create, correct? Those replicas means how many pods you want to run in your Kubernetes cluster. So it may be a single replica, or it may be 4 replicas or 4 pods. Those will be running in your Kubernetes cluster. So this is the basic of deployment. This is how deployment works. Let's go back to our Minikube cluster and see how it works in practical. I'm sharing my screen and I have my deployment.yaml. It is exactly same that we saw in earlier example. There is a single replica. Application name is web server, kind is deployment, and we are associating some resources, CPU and memory. And image we are running is Nginx 1.17. That is a web server. So let me go back to my terminal. We already checked that my Minikube is running. I am inside my Nginx deployment where the deployment.yaml file is available. We are going to run the command kubectl apply and deployment file. And you will see that my web server has been created. We can check in the bottom terminal kubectl get pod -o wide. When I specify option wide, it provides you all the information related to the pod, its IP address, where it has been deployed, and all those things. So you can say this is a web server that is provisioning. It is scheduled on my Kubernetes cluster, but its status is container creating. So it might be downloading that image file, and then it will create the container. Let's watch that. Now it is in running condition. So to watch that at runtime, you can use command watch, that is a Linux command. And N1 means every second run this kubectl get pod command. So we'll be doing that now. You see it will be reflected every other second. Now, what we can do is we know that we said we want to create just one replica. Now you can run that one kubectl scale replicas and deployment, and our deployment name is web server. So now I'm specifying I want to run 4 replicas. Just observe at the bottom screen, you can see that new pods are getting provisioned. So earlier it was in pending mode, now it is in container creation, and soon it will be in a running position. Let's wait for a second. You can also go back to YAML and you can specify that, okay, I want 3 replicas to be created instead of 1 or 4. You can create it through your command line, or you can create it through YAML.file. It is expected or it is a better way or good practice to modify it in a YAML, and then that YAML file or that change will be committed into your Git repository and then apply it to your cluster. So you know what exactly the application status or how many replicas are running in your cluster just looking at your YAML file. Modifying through command line is okay for development, but definitely not for production environment. Okay, so let's go ahead. I'm going to run kubectl apply command again. And we know this time we change it to the 3 replicas. You will observe that 1 has been gone. So it was terminating and it's done. Now we can set the replica set, kubectl get replica sets, and you see that replica set has been created with the web server and unique ID with that. If you see that in production cluster, all these 3 pods can be provisioned over 3 different data centers, availability zones, or 3 different virtual machines. If for some reason that virtual machine goes down or the data center goes down, that pod or that application pod will not be available anymore. So let's try to replicate and see what happens. So what I'm going to do is I'm going to delete the pod, any 2 pods. Okay, and this command. And you see 2 pods have been deleted and 2 pods immediately getting created. This is how the replica sets work. Replica sets in Kubernetes controller knows that how many pods supposed to be running in your Kubernetes cluster at any given point or any given time. So if you delete any pod or for some reason that pod get deleted or crash or that node is not available, that pod will be rescheduled on another node, whatever is available. If node is not available, then it may stuck into a pending state. But Kubernetes try to reschedule that and maintain number of replica sets. If you want to delete that one, you can simply delete deployment web server and it would be gone. Similarly, you can see that at the bottom terminal is gone. You can also run the command kubectl delete and then specify the file and it will try to delete. It's already deleted. It's not available right now, but this is so simple. This is how the deployment works in Kubernetes cluster. I hope you have liked this one. I'm going to stop here now. If you have any questions, you can